Okay, good. Right, so I'm going to talk about an implementation in Hyrax, which is ongoing at the moment. We've just reached quite a good stage this week, which I can explain. And this is to implement a protocol which has been developed by COAR called COAR Notify. So I'm going to start with a little bit of context to explain why we're doing this, and then explain how far we've got so far. So COAR, for people who aren't familiar, is the Confederation of Open Access Repositories. It's a membership organization made up of institutions with open access repositories. It's a really good organization. I've been working with them off and on for quite a few years now. And I like it very much because it's truly global. It's a really global organization. It has members from every continent, and it's quite representative in that sense. So the context of this really is that there is a growing interest again, and these things have been through several cycles, I would say, but there is a growing interest again in the extent to which preprints in open access repositories can be first-class components in scholarly communications. And we're seeing this with the changing funder policies, which are starting to require the deposit of preprints into repositories, for example. Things like Coalition S, Plan S, and others. And I thought this slide was quite interesting. It was put together by Jessica Polka. It's actually quite old now, I think, probably a year old at least. And this is a fairly fast-moving situation. But these are all services which have which interact with preprints in preprint repositories or institutional repositories, largely to do with peer review or some other kind of review or annotation, that kind of function. For the rest of this presentation, I'm going to focus on peer review as something which is of particular interest. And the reason for this is that we were given the COAR Notify project was given significant funding by the Arcadia Foundation precisely to do that, to look at ways of enabling peer review on articles held in open access repositories. So that's the context of what we're doing here. So there's a sort of a strategy and a few overarching principles to what we're doing. So first of all, we were really keen not to build another kind of system-to-system API or system-to-system integration. This is really about connecting the resources within the system. So it's not so much about connecting a repository to a peer review system, so much as it's about connecting an object in a repository to a review in a peer review system. It's about connecting those resources rather than the systems. And so naturally, we are interested in doing this in a resource-oriented way, where resource-oriented is a sort of reasonably precise term from computer science, which describes what I've just said. Another way of putting this is that we really want to pass by reference, not pass by copy. That means that a lot of mechanisms in our sort of digital libraries and repositories and so on are all about exchanging copies of metadata or copies of actual objects and moving them around. And what we were keen to do was to not do that, to respect the fact that these things are distributed in a number of systems, repositories and other systems, and that what we should be exchanging is the URLs, the references to those things. And because all of the systems that we're interested in and all of our open access repositories are web systems, then URLs is the way to do this. We also were interested to find a generalized solution that could be extended into other use cases, not just peer review, because repositories often, probably mostly, exist in fairly low resource conditions, even if they're in a very well-funded university, it's actually quite rare for the repositories themselves to be very well funded or resourced. So we wanted something that would be cheap and that wouldn't introduce, a new level of technological debt for each integration. So the general approach we hit on was asynchronous messaging. This is something I'd been interested in trying to apply to these kinds of use cases for a while. So this is I hope, a reasonably simple diagram to sort of explain generally how this might work. So on the cloud on the left is a repository, and the cloud on the right is a peer review system, and they are communicating with HTTP, with the language of the web protocol. And the idea is that the repository might send a notification using HTTP to an inbox on the peer review system, um, asking for a review to be conducted on one of its resources, perhaps. I mean, there are many possible requests that might happen here. And the peer review system likewise can send a notification to a receiver on the repository, for example, announcing that it has made a review and published it, and here's the link to that review. So these notifications would be very lightweight. They would really just be conveying essentially a request or an announcement or something like that, and a URL and a few other small pieces of information. They're not rich metadata. They're not sending large amounts of content. They're very, very simple. That's the general approach that we were interested in using. And then we were advised, we took advice from various people, and we were advised to look closely at an existing standard from W3C called linked data notifications, which performs in more or less the way I just described. And a second standard, which is activity streams 2, which is really a kind of vocabulary, just a way of describing those kinds of messages. All very simple stuff, all very well established and mainstream. None of this is being invented by us or anyone else. Here's an obligatory piece of machine readable code, which you won't be able to see on your screen, but just by way of illustration quickly, the notifications which are sent in these messages are formatted as in a format which is called JSON LD. JSON LD is a sort of a hybrid between RDF, which is a way of arranging data in a very particularly web-friendly way, and JSON, which has become the sort of de facto machine-readable format for exchanging stuff on the web. I won't go into those in detail. At the end of this, I will have a URL where you can go and read all about the COAR Notify protocol in detail if you're interested. So what we've gradually been developing, we being the COAR Notify project, I haven't got to Hyrax yet, so I'm about to get there, don't worry. What we've been developing is a series of sort of conventional arrangements for using these messaging patterns for achieving things, working in partnership with repositories and with peer review services. And on the screen, that's an example of one of those interactions which we've worked out. So this is live. This is working with a review and endorsement service based in France called Peer Community In, which runs about 16, I think now, communities of interest around particular academic domains, where those people will review and optionally endorse a piece of scholarly output, a paper. We have used Notify to allow repositories to send requests to PCI for endorsement of one of their preprints. And this on the screen here is essentially the workflow which is followed using COAR Notify. So if you can see the difference in colors there, the purple or lilac, is it? things on the screen are the notifications which are exchanged between a repository and PCI. And this is now available in several repository platforms. It's available in DSpace, ePrints. Invenio is almost done. I mean, it's I think the development's been finished in the last week or two, and it's about to go live, which means it will be available in Zenodo, which is quite exciting. And there are a few other repositories, less well-known ones, which have implemented this. So that brings us to Samvera, and specifically Hyrax. So we're working on two developments. And when I say we, this is my company Antleaf working with Cottage Labs, who some of you will be familiar with, who are doing the actual software development here. I'm supplying from Antleaf the Notify expertise and the project management. So the reason there are two developments is we want to kill two birds with one stone here. We want to enable Hyrax to be able to participate in these Notify interactions. But the COAR Notify project also has a requirement to develop a standalone inbox, which could be used by other people with other systems and doesn't have to be deployed with a particular repository system. And it was actually Tom Roble at the Bodleian Library who gave me this idea, which is that since Hyrax is deployed as what is called a Rails engine, as a sort of sub-application within a Rails application, a Ruby on Rails application, we could do the same thing with the inbox. So we could make it a component which could be deployed by itself, or it could be deployed alongside a Hyrax repository and effectively would be embedded into that repository. So that's a nice arrangement which gives us the option and which satisfies our general requirements at COAR to be able to have a standalone inbox which other people could use outside of a Hyrax or Samvera context. So the project has these two developments to first of all develop the COAR Notify receiver. This is the inbox. And then to develop the Hyrax support for using that to receive Notify events and do something with those, COAR Notify notifications, messages, and then do something with those messages. And essentially, we think that what it boils down to is using Hyrax workflows for reacting to those notifications. We need a dashboard to allow the Hyrax administrator to be able to see what's going on and be aware of the notifications that are being received and what's happening. We think there's probably no need to extend the Hyrax model at all, actually, because pretty much everything that results from a Notify notification in all of our common use cases is really just the establishment of a relationship between, in this case, a Hyrax work URL and the URL for something in a separate system, like the URL to a review or an endorsement or something like that. Specifically, we're going to support two COAR Notify workflows: the PCI endorsement review workflow, which was the one I just showed the workflow diagram for, and a second one which is quite popular, which is a very simple workflow where one repository sends a notification to another repository saying, I have something which is related to something you have. And the kind of canonical use case for this was established and first built by Harvard University using COAR Notify, which is where they wanted their publications repository, which is a DSpace repository, to announce that it had a paper which was in some sense derived from a data set in their Dataverse data repository. So we will be implementing those two possible workflows for Hyrax. So this is just sort of illustrating the point I was trying to make earlier about the two possible configurations. So in this configuration, we have two Ruby on Rails applications. One has Hyrax embedded in it as a Rails engine. The other has the COAR Notify receiver as a separate Rails engine, and they communicate using HTTP. The other approach is to have a single Rails application which has Hyrax embedded in it as a Rails engine. This is the usual arrangement for Hyrax, but it has a second engine embedded in it, which is the COAR Notify receiver. I think in most cases, if people want to use this in Hyrax, they're going to use this approach. What we found with the other repository platforms is they haven't even bothered separating out the inbox at all. But with Hyrax, you will have the option. So the two developments, the first development is to build the linked data notifications receiver as the standalone or optionally embeddable Rails engine. And the initial development on this was completed this week. So we're literally, the meeting we had was yesterday where we discussed that. So we'll begin testing this this week. So this will be outside of any Hyrax context. This would just be testing that inbox can receive and handle COAR Notify notifications. But this means that the development of the Hyrax support can begin very shortly, could even begin today, really. Something I'm very grateful for is that the Hyrax product and tech leads, Nick and Randall, have been, and Daniel, sorry, on some other calls, have been joining us fairly regularly. And so the development we're going to be doing in Hyrax and the discussions we've had so far about how to do this, we're being careful to align that with the sort of norms that and expectations within the broader Hyrax development roadmap. But what we expect to do is to distribute this as a gem, which will include a generator, the workflows, a dashboard, and a few other bits and pieces. So this is my final slide. I just wanted to put some URLs in. So if you want to read more about the COAR Notify protocol, then that first URL at the top there, that's the one to go to. It has the actual protocol, the technical documentation for that, how to implement it. It also has links to low-level code libraries in a variety of languages to support Notify. Ruby is one of those, and that's the library which we'll be using, or we have been using in the project here. It also has documentation for the workflows like the one I showed earlier. That's from that website. So you'll find a lot of information there. Those are some of the, those logos are some of the organizations and products and so on which have implemented COAR Notify so far. And then below that, I've got two GitHub repository URLs, which are for the two developments I've just been describing. So the first one is the standalone COAR Notify inbox, and then the second one, which is not really doesn't have much yet, will be the Hyrax gem. I'm hoping that we will get all of this developed before the end of this calendar year, but we may possibly go over slightly into next year. But certainly real soon now. That's the intention. So that's me. I'll stop talking. I've left. I went through that very quickly and left a bit of time